Hello, everyone. I'm Xizhao Bao. It's a great honor to be here for presentation. And our paper is unsupervised motion capture data segmentation based on topical model. First, I will talk about what motion capture data segmentation is. It is to segment a motion capture data sequence according to motion types. This segmentation can improve the readability of motion data and make it easy to store, so that the motion capture data can be better used in the field of movies, games, sports training, and so on. This is our segmentation result. We use different colors to represent different motion types. You can see that our segmentation result is good. Okay, for the task of motion data segmentation, there are some challenges. First, human motion capture data has a high degree of freedom. As shown in the picture, human skeleton have many joints, and each joint has a multiple rotation axis. Second, variability is complicated and changeable, and different people have different poses. Third, there is a mixed motion primitives problem. That is, the ascent fragments are highly similar. As shown in the picture, the fragment between walk and run are very similar. Moreover, the number of motion types is unknown too. The previous work are three kinds of methods. PCA-based, model-based, and clustering-based. The PCA-based methods are to reduce the dimension of motion data, analysis the internal dimension changes of different motion, and then segment the motions. The model-based methods are to apply the mathematical model to the segmentation task. The most frequently used models are Gaussian mixture model and hidden Markov model. The clustering-based methods transform the segmentation problem into a clustering problem. According to the similarity between samples, the motion sequence is dividing into several behaviors belong to different motion types. In addition to the above three methods, some researchers transform motion capture data into different representations, such as graph, images, strings, and words. For example, Yangtze convert motion capture data into image data, and then use the image classification technology to solve this problem. Similar to previous researchers, we also consider converting motion capture data into other types data. We compare the motion capture data with the topical model of natural language processing. In NLP, each document in a corpus have one or more topics, and each topic is related to some words. For motion capture data, each motion has one or more motion types, and each motion type is composed of some poses. Therefore, we think that the topical model method in NLP can be used in motion capture data. Specifically, for motion sequence to be segmented, we first use the sliding window to get the fragment and then represent the fragment as a motion document. In order to get the topical distributions of this document, we use the topical model. Finally, we cluster the topical distributions to find the segmentation points. First, I will talk about how to use the sliding window. For a n frames motion sequence, we use a window of W frames to slide from the beginning. to the end of the date to get n plus n minus m plus 1 fragments. Each fragment represents its middle frame motion date. After getting the motion fragment, we cannot use the topic model directly. We need to represent them as a document. A topic model usually regards text as a bag of words. For natural language, this is a simple thing, but just need to take a seat according to the vocabulary. But for motion capture data, there is no vocabulary. We have to generate a motion vocabulary to complete this conversion. We use a hierarchical clustering for datasets, more than 100,000 frames to get the motion vocabulary. Every word in the motion vocabulary is a different pose. And after generating the motion vocabulary, we can represent the motion fragment as a bag of machine words. Now we can use the topic model on the motion documents. For natural language processing, topic model can extract the topic distribution of documents. For motion documents, we can extract the motion types distribution of motion documents by using topic model. There are many classical methods of topic model, such as LDA and PLSA. After comparison, we choose the sparse topic model, STC, because it can extract a more sparse topic distribution. The picture shows the distribution of 6 kinds of motion extracted by STC, and we can see that the results are very sparse. In this way, by using STC, we get the topic distributions of each document. Now we cluster these distributions to complete the segmentation. We could cluster the distribution and observe the change of label. If the label of the class changes, this is a segmentation point. For the choice of clustering method, we choose spectral clustering. So far, we have finished the segmentation of motion capture data. Let's review it briefly. We first use the sliding window to get the fragment and then represent this fragment as a motion document. In order to get the topic distributions of this document, we use the topic model. Finally, we cluster the topic distributions to find the segmentation points. Okay. Another problem to be solved is the value of super parameter, which is a number of motion types. The number of motion types K is also the number of topics in the document. In most tasks, K is usually unknown. In order to find the optimal K value, we first estimate the range of K, then calculate the silhouette coefficient K in the range and take the K value with the largest coefficient as the optimal K value. To check the performance of our method, we did 4 experiments according to dataset, subject, and motion types. In the experiment 1, we used the mocap dataset where the subject and the motion types are both known. The purpose of this experiment is to check the effectiveness of our method. In experiment 2, 3, and 4, we do experiments on unknown datasets, subjects, and motion types to check the generalization performance of our method. It should be noted that for our experiments, we used the same vocabulary. which was generated from the CMU mocap dataset. Okay, in experiment 1, we first qualitatively analyze our method. We do experiments on 14 sequences in subject 86 of mocap dataset. This picture shows our results. The red line is the truth, and the green line is our method. It can be seen that our method has a good segmentation on most of that. For some sequences, such as 13th and 14th, we have some errors in particular some segmentation because they have very short motion clips, even smaller than the sliding window size. In experiment 1, we further examined the performance of our method quantitatively. Our method achieves a range accuracy of 94 on the data mentioned above. A detailed definition of accuracy and error can be found in our paper. Next, we compare our method with ACA and HSA. Each result contains 4 rows, which are ground truths. Our method, ACA and HSA. It has been seen that the segmentation results of our method are similar to them, and our method performs better on some motion data. In the second motion sequence, ACA and HSA put the first segment stand still in the same class as the first segment walk, but our method can distinguish them. In the fifth motion sequence, our method gives the first segment point that matches the ground truth, but the AC and HSA didn't detect this segment point. In the 11th motion sequence, AC and HSA mistakenly divided the fifth segment into two motion, where our method didn't. Through experiment 1, we found that our method performs very well on no data. Furthermore, we examined the generalization performance of our method in the following experiments. In experiment 2, we examined the performance of our method on unknown subject data. From the picture, we can see that our method still has a good segmentation of unknown subject data. In experiment 3, we concatenated CMU mocap data and HDM data together for experiment. One CMU mocap data includes walk, jump, punch, leg kick, and one HDM data has a walk, leg kick, punch. Pictures show that our method not only segments the HDM motion data well, but also recognizes walk and punch, which are from 2 different data sets as the same type of motion. This experimental result shows that our method is not only effective on the HDM dataset, but also can identify the same type of motion in different datasets. Okay, in experiment 4, we tested our method on unknown motion types and unknown subjects from HDM. The data include 5 motions. Although there are no jog, bendness, and walk with bendness in the original 14 motion sequences, which is our vocabulary. But our method can still segment different motions correctly. Pictures shows the results of our experiments on unknown types of motions. Although our method has some difference in accuracy for different subjects, but all of them can be segmented correctly. In conclusion, we propose a novel method based on NLP, and experimental results show that our method has a good segmentation performance and a good generalization performance. In the future work, we will improve the quality of the motion vocabulary and experiment on larger data set. Okay, thank you for your watching.
That's great. Thank you, Xizhao. So that's much appreciated for the presentation. So for all the audience, please feel free to type your questions in the chat box or in the Q&A so that we can pass it on to Xizhao. So I don't know if any question coming from the panel. So if any panel, while we are waiting for more questions.
I have a question.
Yes.
So it seems that the topic modeling approach seems very good for the clustering. So I'm wondering how specifically you could create that motion vocabulary. Could you give a more detail?
We just use clustering to generate the motion vocabulary.
So can I follow this question because I'm quite curious about the vocabulary. So for the vocabulary, is a single pose just one frame or it's multiple frame?
One pose.
Okay, it's just one pose. And
one word represent one pose.
Okay, so that's in a pose. So that's you can using as many poses as possible to create as many words as possible. Is it true?
500 words.
Yeah. And also for once the poses are defined, so if we have a new set of animation or mocap data coming, so if the mocap data are using different skeleton topology, can your method still work? Or if not, what the potential way to make it working?
Okay, I don't understand the
question is that if in your case, so if the pose is giving as using attached to a particular skeleton, so if a different configuration of the skeleton, so they're like more joint or more segment, more joints or
okay.
Different. What would you do? So in that case,
we have not tested on other skeleton.
Okay.
In CMU mocap dataset, the all skeleton is the same.
Yeah, that's good. Okay, thank you. So any questions from? I didn't see any input from the chat or question answers.
I have a question. Can I ask a question?
Yes, please, Chris, go ahead.
Sorry, I just put my video on. So what I wanted to know is if you have, so you're really looking at the delimitation of your actions through a windowing system, but what happens if you have, for example, a mixed action in the bottom of your body and a different action at the top? So for example, you've got like a walk on the top, but you're doing more of a punch at the top. Can you distinguish those as well, or it's sort of next stages?
Yes, we can distinguish different motion types.
But as two separate types, or just as a combination of one type? Do you see what I mean? Like, can it say this is a walk and a punch, or it says this is a walk punch?
Oh, okay. We can't. We will put them as three types: walk, punch, and walk punch.
Okay. Okay. Cool.
It's a quite interesting point. So, like a set of animation could be, you know, sometimes might be more meaningful or might be useful. I think in some particular case, that's a good point from Chris. Thank you for the input. Yeah. So, if there's no other question, I think we will move on. So, maybe Xizhao, you can share your screen.
Okay. Thank you.
Thank you. So next,
I have a question.
Yes.
Jan?
Yeah, Nadia, please. Yeah, sorry.
Yes. I would like to ask the presenter, what does he think is the most original part of his paper? What is the novelty?
Novelty. In our
In comparison with the state of the art, what is the most striking contribution?
the most contribution is we propose a novel method that based on the topic model. This is a new method in this task.
But what is specifically new in the model?
Not a new model. We use the STC model.
Yeah, I think it's about somehow to apply this AI model for motion capture analysis. I think this quite inspiring. I think for this area. So I can see lots of parallel works development in this area. Yeah. So if there's no other question, I think we could move on, and then if there are other issues, so that you're welcome to contact the author, and either in the socialized social time, or in the break, or by email, etc. Sorry, Nadia, to cut short, just to
Thank you.
really worry about the time.